Alright, so in this video, we're going to determine every possible 5-block polyomino. Now, if you recall, a polyomino is basically a set of squares that are all touching each other side to side. And so basically, here we have 0 squares, here we have 1 square, here we have a 2-square polyomino, here we have all possible 3-square polyominoes, and here we have all possible 4-square polyominoes. Well, as you can see, just looking at the 4-block polyominoes, each different case is a different combination in which the blocks touch each other, right? Not a single one of these cases can possibly map onto another case. So what about if we have a polyomino consisting of 5 squares? Well, we could have 5 in a row, but it turns out you can determine every possible 5-block polyomino by building off of the cases of 4-block polyominoes. So what we're going to do, basically, is we are going to determine every possible 5-block polyomino first that has 4 blocks in a row in it. So we're going to build off of 4 blocks in a row. Well, we're going to work at this systematically by starting by placing our 5th block in the top left corner, and we're going to work our way clockwise. Right, just like that. And so starting here, well, we have a 5-block polyomino. We don't see 5 blocks in a row, so it's clearly not identical to this case. Therefore, we know that we've discovered a new polyomino. Right, let's go back to what we had before, which was 4 blocks in a row. Instead of placing a block right here, what if we place it right here? Well, we don't see 5 blocks in a row, so it's clearly different from this case. But this case is also clearly different from this case, so we know we've discovered a new case. Going back to 4 blocks in a row, instead of right here, continuing to work our way clockwise, if we have our block right here instead, notice we don't have 5 blocks in a row, so it's clearly not this case, but it's pretty obvious that this case is identical to the case before it, because they're mirror images of each other. So really, all you would have to do is reflect this about some imaginary line, and as you can see, you can just translate this onto this one. So that is how we know for a fact that this case is identical to this case, right? So as a result, this is not a new case that we discovered. Okay, continuing to go clockwise, if we have our block right here instead, we can now clearly see that this case is identical to this case, so we've already discovered it. If instead we go right here, well, that's 5 blocks in a row, and we've already discovered 5 blocks in a row. If instead we're right here, well, notice this case is identical to this case, right? As you can see, this case is identical to this case, right? And if you keep going, we've already discovered this one, we've already discovered this one, we've already discovered this one. And we're back to where we were before, which was the top left. So at this point, we have discovered every possible 5-block polyomino that has 4 blocks in a row. This right here is every possible 5-block polyomino that has 4 blocks in a row. So we've discovered every possible 5-block polyomino by building off of this case. So now what we're going to do is we're going to build off the next case, which is this one right here, right? Really, we're going to work at this systematically. We're going to place our 5th block in the top left corner, right? Just like last time. So, as you can see, we have a 5-block polyomino, and notice we don't have 4 blocks in a row, which means it can't possibly be identical to any of the cases we've previously done. As a result, this is a new case. And I'm going to call this my starting point. All right, and the reason why I'm establishing this starting point, you'll see why it's useful in a moment, but basically it's the starting point for all possible 5-block polyominoes that consist of this case. Okay, so instead of placing our block right here, what if we place it right here? Well, again, notice we don't have 4 blocks in a row. Therefore, it can't be any case before this starting point. In other words, it can't be any one of these cases. Therefore, the only case that this could possibly be identical to is this one. But clearly, this case is not identical to this case. So, because this case is not identical to this case, that's how we know we've discovered a new polyomino, right? And that's basically it, right? Continuing with that same thing that we're building off of, instead of right here, we have it right here. As you can see, we don't have 4 blocks in a row, which means it can't be anything before this starting line. Therefore, this case could only possibly be identical to this one or this one. But clearly, this one is not identical to either one of these. So we know for a fact that this is a case we have not yet discovered. So that's a new possible 5-block polyomino. Okay, instead of having a block right here, what if it's right here instead? Well, notice we have 4 blocks in a row. But we've already discovered every possible case with 4 blocks in a row, right? So it must have been discovered somewhere in here. Therefore, this is not a new case. Instead, what if we have a block right here? Well, it turns out that this right here does not have 4 blocks in a row, which means it can only possibly be one of these cases, but this is actually a new case, right? This case is not identical to any one of these. In fact, because this case is there is no instance where we have, basically, this case spans 3 by 3. This case spans 2 by 3. This one spans 2 by 3. This one spans 3 by 3. Because this case and this case are the only ones that span 3 by 3, that means that what that means is that this is the only possible case that this case could possibly be identical to. But clearly, this case is not identical to this case. That's how we know that we've discovered a new case, right? And that's basically the idea. So if instead of being right here, we're right here, well, again, this is not 4 blocks in a row, which means it can only possibly be one of these 4 cases, right? But I'll leave out the long details. We know that this is a case. We know that this case is not identical to any one of these 4, so we know that we've discovered a new case. Right, and continuing going, if instead of being right here, we have our block right here, well, as you can see, we do not see 4 blocks in a row, and it's not identical to any one of these cases, right? As you can see, it's basically the letter T, and we haven't discovered any one of these, there's nothing here that really resembles the letter T. Like this one sort of does, but clearly this and this are not identical. So we know for a fact that this is a case that we haven't yet discovered. So yeah, it's pretty much the idea, right? If instead of right here, we continue going clockwise and we're right here, well, we have 4 blocks in a row. We've already discovered every possible case of 4 blocks in a row, which means we've already discovered this case before. Now, if instead our block is right here, notice we don't have 4 blocks in a row, which means it can't possibly be any one of these cases, right? But notice that this is actually the only case that spans 4 by 2. None of these cases here span 4 by 2, which means that this case can't possibly be identical to any one of these. And that's how we know that this is a new case we have not yet discovered. Instead of right here, we're right here. Well, we're back to where we started, right? We started in the top left corner, so that's how we know we're done. So we have discovered every possible case, right? We've discovered every possible 5-block polyomino that consists of this structure. There's quite a few of them, right? Now, basically, yes, we've discovered every 5-block polyomino by building off of this thing. So now we move on to the next one, right? Now we're going to build off of this one, right? So now that we're building off of this one, right? Again, we're going to work at this systematically, starting in the top left corner. What if we have a block right here? Well, we don't have 4 blocks in a row, which means it can't possibly be any one of these cases. But notice something really important. We see that this exact structure exists in this polyomino, which means since we've already discovered every possible 5-block polyomino that consists of this structure, that means we must have already discovered this structure somewhere in the past. In fact, it's right here. So we've already discovered this structure. So we have to move on. Instead of right here, what if we have a block right here? Well, again, notice that we have that same exact structure right here. We've already discovered every possible 5-block polyomino that consists of this structure, which means we must have already discovered this one somewhere in the past. In fact, this is our letter T. We've already discovered the letter T case, right? So again, continuing clockwise, if instead our block is right here, well, it turns out we've already discovered every case with this structure, so we know for a fact that this is not a new case. If instead we have a block right here, well, that's 4 blocks in a row. And we've already discovered every possible case with 4 blocks in a row. So we are good there. If instead our block is right here, again, notice we have that same exact structure. If instead our block is right here, well, notice now that there is nowhere in this structure that we have this, right? This case is not present anywhere in this structure. And since it isn't 4 blocks in a row, we know for a fact that this structure is not going to be identical to any of the ones that we've discovered in the past. As a result, we know for a fact that this is a new polyomino. Okay, if instead of right here we have our block right there, well, as you can see, we have that same structure, right? We have that same structure, so we've already discovered this one. If instead we're right here, well, this is 4 blocks in a row. We've already discovered every case with 4 blocks in a row, so we're good there. And we are back to where we started, which was the top left corner. So as a result, we have discovered every possible one of these cases. And by the way, I forgot to include a starting line, right? If you recall, I included a starting line for this case. I forgot to include a starting line for this case, but as you can see, there was only one case that consisted of this, so it wasn't really that big of a deal. So instead of building off of this case, what if we build off the next case? Well, basically, we are building off of this case, but here's something really interesting. We have built off of every possible 4-block polyomino that consists of 3 blocks in a row. As you can see, 3 blocks in a row at least, 3 blocks in a row, 3 blocks in a row, but every case after this does not consist of 3 blocks in a row, only consists of 2 blocks in a row. Since we built off of every 4-block polyomino that has 3 blocks in a row, that means we've discovered every 5-block polyomino that has 3 blocks in a row. So that means we should not discover any more 5-block polyominoes that consist of 3 blocks in a row. But notice, when we build off of this case, no matter where we place our block, we're always going to get 3 blocks in a row somewhere. It turns out it's always the same case every single time, right? If you recall, it's that case that we discovered way back here. And so as a result, there's no new cases that we discover from building off of this structure. So we don't even have to worry about that building off of that case. So now that we're through with building off this case, we have one more possible case we could build off of, which is this one. Again, we shouldn't discover any possibility of 3 blocks in a row. So again, working at this systematically, suppose we place our block in the top left corner, and we're going to work clockwise, so we discover every possibility systematically. Well, notice, when we place that block there, we get 3 blocks in a row. And because we have 3 blocks in a row, well, we've already discovered every case that has 3 blocks in a row, which means we must have discovered this case somewhere in the past. In fact, we did. It's literally right here. So we're all done with that. And, okay, what if we place our block right here? Well, again, we have 3 blocks in a row, so we must have already discovered it. We place our block right there, again, 3 blocks in a row. But if we place our block right here, notice that there is no instance where we have 3 blocks in a row, which means since every case before this has 3 blocks in a row, this must be a new case because it does not have 3 blocks in a row. So that's a new case. And I guess just to get into a good habit of it, I'm going to establish my starting line for all possibilities consisting of this case. Should probably move it a little closer up. So if instead of having our block right there, we have our block right here, well, again, that's 3 blocks in a row, so we must have already discovered that. 3 blocks in a row, so we've already discovered it. 3 blocks in a row, so we've already discovered it. But if instead we have our block right here, well, notice this is not 3 blocks in a row, which means it can't possibly be any case that we've discovered in the past. The only possibility that this case could be is this one. And notice that this case is actually identical to this case. It turns out you could actually rotate this case 180 degrees, I believe. Yeah, you could rotate this 180 degrees and then translate it directly onto this one. Right? They both represent a tiny letter W. Right? As you can see, they're visually identical. So we've already discovered this case. So if we have our block right here, we are back to where we started. As a result, we have discovered every possible 5-block polyomino that consists of this case. So at this point, we have discovered every we've discovered every 5-block polyomino that's built off of every single one of these 4-block polyominoes. But really, as we stated at the beginning of this video, every single 5-block polyomino can be built from each case of from a case of a 4-block polyomino, which means we have discovered every possible 5-block polyomino in existence, provided with the definition that we know of as a polyomino. So how many cases do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 possible 5-block polyominoes. Yeah, so 12. So as you can see, our pattern currently goes 1, 1, 1, 2, 5, and now we have 12. Again, there still doesn't appear to be any apparent pattern going on here. It doesn't seem like it's very obvious how you can predict what the next term in this sequence would be. But nonetheless, it's pretty interesting, right? It's all different combinations in which we could attach squares to each other side by side, right? And that's really the whole idea of it. So yeah, that's pretty much it for this video.